Hello, I am Anand Talwar, Technical Marketing Engineer with HP Aruba Networking CX Switching team. And today in this elevator pitch session, I am going to talk about a new feature we are going to release with AOS-CX 10.15, which is known as Inband Flow Analyzer, or commonly known as IFA. So let's get started. Now, IFA is a telemetry feature which provides hop by hop visibility into your network by embedding collected details into data packets directly as they pass through your network. It essentially includes metadata for metrics such as latency, congestion, and queue depth. These details are added to something we call as IFA probe packets. So let's see or what these IFA probe packets are. So CX switches enabled with IFA samples incoming flow packets at a user configured sampling rate, clones it and alters it to perform further IFA operations. Metadata for each hop is added in this packet and is passed to the next node, and the cycle continues further till the flow terminates. Let's see a bit of how this feature is working in real time. So there exists three types of nodes in context to IFA. Number one, an initiator where the flow is observed first, is sampled and altered to create an IFA probe packet. At the same time, the initiator is the point where metadata of first node is added. Next, we have transit, which identifies IFA packet coming from last node and updates its metadata to same packet. Finally, we have terminator. This is where the collected IFA metadata is extracted and is exposed to the end user. It should be noted that there can exist more than one transit node between initiator and terminator. Let's see how incoming flow will be dealt in case of IFA configurations. So in this case, we have two hosts contacting each other. The first host is sending a flow that is acknowledged by the initiator node. The initiator node samples this flow and creates an IFA probe packet and adds its metadata to it and then passes it to the next node. The next node is transit node, which acknowledges this IFA packet and updates its metadata to the same IFA packet that has been passed from the initiator node. Further, once this is done, the flow moves towards the terminator. This is where the terminator will identify the IFA incoming IFA packet and it segregates the data where the original flow will go ahead to its destination and the IFA collected IFA data will be sent to the collector via REST if configured or is exposed to the user via CLI. So once again to reiterate, the collected metrics can be exposed to the user via CLI or REST. Here is a bit of view of how these nodes can be configured. All the three nodes has different configurations that needs to be done on each of these profiles or on each of these switches. For instance, for initiator, initiator is the point where the flow comes in first and is sampled. Plus, you can filter out the flow of your interest as well. So here is a snapshot of what configurations are required to be done on initiator. In case of transit and terminator, one needs to enable the terminator or the transit monitor, which will keep an eye on all incoming flows and will check out for IFA probe packets where they can append the data in the case of transit node. In the case of terminator node, the data can be collected from it and can be displayed to the user. Now, one crucial point that should be noted here is that currently IFA is a part of CX Advanced Feature Pack offerings. Considering the use case of this specific feature, it helps in monitoring end-to-end and per hop latency or congestion of a particular application or flow of interest. Also, IFA can be leveraged as one of the major tools in meeting network service level agreements. Talking about the customer benefits, IFA is considered as the in-packet telemetry, which brings minimal overhead to your system. At the same time, the addition is no synthetic packets are generated in case of IFA, since it instruments the actual flow packets for IFA operations. This makes sure that the telemetry data collected has the similar behavior as of your original flows. Talking about the supported platform with the release of 10.15, currently IFA functionality is available on two of our 9300s, which include 9300 32D and 9300S models. So as I mentioned, this is a quick view of IFA. If you want to learn more about the details, configurations, troubleshooting, and want to look at a demo of this particular feature, please feel free to refer to 10.15 update on Inband Flow Analyzer. At the same time, to get regular and latest updates on our solutions and our products, please feel free to join Airhead's community. Here is a QR which will help you to reach out to there quickly. So with this, thank you all for watching this video and see you in the next session.